Hello and welcome back everyone. Assalamu alaikum. So today I am going to talk about the supervised learning workflow in a little bit more detail. So just laying some groundwork, how we define a training set and what mathematical symbols we use and some terms that we will be using. So just to briefly outline, let's just talk about how supervised learning works. So supervised learning is like the process of regression or classification. So there are essentially two steps. One is the training step. So we train a machine learning model, and the second step is the inference step. But before we get into the inference step, let me talk about the training step first. So imagine you have a training dataset, and your task is, in this case, let's say classification, and you want to classify something. Let's maybe pick a simple example of classifying different flowers. So let's say you have on different flowers. And there might be different flower species, and you're interested in classifying how or what type of flower it is based on an image. So you collected multiple flower images, that's your training data set, and you also have consulted an expert to provide you with the labels. So it could be, for example, let's say this is an iris flower, this is a rose, and the third one, let's say it's a sunflower or something like that. You can think of any flower. So you have these labels, and there are your labels that you want to predict, and the flowers, like the picture of flowers, these are your observations. So you have collected maybe thousands of those. This is your training data set. And in traditional machine learning, what you would do is you would extract some features. So usually traditional machine learning algorithms don't work very well on image data. So you would extract some features, and here again you would need a domain expert, and having someone's opinion like what could be a good feature, you can think about it. But also usually it's good to consult an expert who knows a lot about flowers, and it also helps like understanding the data set set a little bit. So one might think, what could be a potential feature? It could be maybe the color of the flower, and maybe height of the flower, and other aspects on the number of leaves and so forth. So there might be different features, and you have to think about what could be a good feature, and also what would be a feature that you can obtain from the image data easily. So you have that. If you have these features and also the labels, you can then train a machine learning algorithm to make predictions. So after you are training the model, in this step we say training. We can also say fitting the model or parameterizing. The model depends on what model we are talking about. Some models are non-parametric models, so we don't really update weight parameters in the model. So in that case, parameterizing would not be a good fit. But these terms, training, fitting, and parameterizing, are kind of synonymous in the context of deep learning. Now let's say we have our model, that is our model that we learned from the data or parameterized based on the training data set. Then the other goal is to make predictions on new flowers, because the whole goal about developing the model is to use it in some prediction tasks. So for example, if let's say you have a website and you have to develop that website where people can upload pictures of flowers, and then your pipeline can predict what type of flower it is. So you would have new flowers, new images, that would be feature extraction step for these flowers. And the feature extraction step is exactly the same as during training, because your model has learned to work with this data that it has seen during training. So you have to have the same feature extraction steps here. Then you have your model, and then you can use it to predict new labels, and this is nowadays called inference. So inference it's a little bit different from statistical inference. It just happens to be called inference, but it's really like, you can think of it as prediction on new data or something like that. Alright, so this is the typical supervised learning workflow: training a model and then using it. However, somewhere in this process, we also want to evaluate how good our model is before we employ it in the real world. So how do we evaluate the performance of a model? This is relatively similar to the inference step. However, we use a test set for that. So the test set, it looks like the training set, but it is usually independent from the training set. So if you have a large data set, let's say you have a very large data set, what you usually do is you shuffle the data set and then randomly divide it into large portions of for training. Let's say 70% for the training and a smaller portion for testing. Well, let's say 30%. And usually there is a third split as well. So this is training, but this is also only an approximate number. 30% for testing. You can maybe also well, it actually depends on the data set size. We'll also talk about that later, but you can also just make this a little bit smaller, let's say 20%, and then make the other one maybe let's say keep it to 70%. And then there could be a third data set that's 10%, and that is validation set that we use for tuning a model. So for now, consider this test set, and this test set here looks very similar to the training set. We have observations and labels, and now what do we do through so we have this step here which is like the inference step. So what's going on here is the same as I have here on the right hand side, like the inference step, the same step, but what we do now is we have these known labels. So we separate from the test set observations and labels, we keep them separately. So we use our labels here, we withhold them from the model because there is no training right now, and then we use the observations as we treat them as new observations. We pretend that they are new. So we pretend these new labels, and then we do our feature extraction step, give the model give the data to the model, and the model makes predictions. So we have now two sets of labels. One are the known labels. We know them because we had them in the test set. They are sometimes also called ground truth data. So that is also sometimes they are also called ground truth data. And we compare these known labels to the predicted labels, and then we can count the number of times often our model makes a correct prediction. And then we can for example compute the accuracy. If we count the number of correct predictions over the number of total data points in the test set, that gives us the accuracy. And similarly, we can compute the error by 1 minus the accuracy. So it's like the basic workflow of a supervised learning model. Now regarding the data, regarding the flowers, so I also wanted to briefly discuss the difference between structured and unstructured data. So a structured data set is, you can think of it as a tabular data set, or a data set that yet it looks like a table essentially. And this is something where you have the data set organized as follows, where the columns are your features and the rows are your observations. So let me go back a step. This is a table you may get during this feature extraction step. So this is something a human has to do, or you can also automate it in certain points. But imagine the original data. Also, the original data would look like an image. So the original data is the flower. You can observe it either in the real world, or you can take a picture of the flower, and then as a human you can use a ruler and then make the measurements about these petal and sepal leaves. So the sepal and petal are these leaves here, and then you can measure how long they are and how wide they are. So here I have a table of sepal length and sepal width, petal length and petal width. Either from an image, from image would be a bit hard because it's not three-dimensional, but let's say an observation in the real world. So this could be then your tabular data set here. These would be your 4 features. We have 4 features here on the right hand side. This is the label that we want to predict included in here in the same table. This would be an example of a structured data set. In contrast, an unstructured data set would be the raw data, for example, the image here. So this would be an unstructured data set. Sometimes we also just call it the raw data, so you can actually extract the structured data set from the unstructured data set. But it's not always very simple, because for example, sometimes you can automate it here, but it might be hard to automate it, and you have to have some human helping hand with that, like maybe even taking the floor taking a ruler, taking a flower and making measurements on the structured data is something where we use traditional machine learning, and unstructured data is something where we can use deep learning, because deep learning has internally a feature extraction step. It's implicitly doing this feature extraction for us. The downside is, of course, we need much more data. For example, here this iris data set only has 150 flower examples, and this is sufficient for regular machine learning algorithms. Like for traditional machine learning algorithms such as random forest, you can easily get something like 99% accuracy with a random forest on this data set. If you want to get 99% performance with deep learning on the flower species prediction task, you would at least have 10,000 images of these flowers to get, let's say, within the 90% accuracy range. So this is 3-class prediction problem, so it would be requiring much more data, and not in every scenario you have such a large data set. So here's a nice summary that I've found in this book. It's a nice cartoon illustrating the difference between structured and unstructured workflow, where you have traditional machine learning versus deep learning. So here on the left hand side, this is the workflow for deep learning, essentially where you have the data and then you throw it into the network. It's like a black box, and then the output is some prediction. And on the right hand side, this is the traditional workflow where you have a human extracting the feature from the data. So you have these handcrafted features that you then provide to the machine learning system and then do the predictions. So it's essentially highlighting the difference between unstructured and structured workflow or data sets. So the structured data would be this one here in the center, where you have the handcrafted features. And just to overlay with the example I've just shown you with the flowers, so on the left hand side, for the deep learning context, you would just give this model the raw images, and the model will figure out what features to use. So it will learn certain features extractions. We will talk more about this when we talk about convolutional neural networks later. They would implicitly learn how to extract features, and in contrast, the machine learning workflow with the handcrafted features here on the right hand side, where you have these handcrafted features such as you're taking measurements here. That's just a brief overview of supervised learning workflow, and how machine learning is different from deep learning. So in the next video, I want to introduce some of the necessary notation and jargon.